When energy transfers to a mass of air, the warm air expands due to increased kinetic energy. Expanded air is less dense, so it tends to go up as cooler, denser air flows under the warm air. The mass movement of warm air upward is convection. Convection is generally considered an energy transfer process, but it might be more accurately described as energy and matter transfer. Rising warm air, including water vapor, brings energy into the upper troposphere. This energy drives many of the weather processes that we recognize, including rain, wind, and severe weather. A traditional convection cell starts when air heats up over warm land or water. The tropical ocean spawns the largest convection cells on Earth. The warm air expands and rises. As a mass of air rises, it cools. Cool air contracts and becomes denser. The denser air falls back to Earth, where it might warm again and rise. The nominally circular flow in which warm air rises, cools, and falls is a convection cell. Warming up a region of fluid makes it less dense, so the buoyant force on that region of fluid exceeds the weight of that region of fluid, and the warm fluid rises. Wet air is less dense than dry air. The reason is that the weight of the water molecule is far less than the weight of nitrogen or oxygen molecules. Water vapor has a density of about 80 thousandths grams per cubic centimeter. In comparison, air has a density of about 13 thousandths grams per cubic centimeter. Water vapor is significantly less than air. So as water vapor enters a mass of air, the density of the mass decreases. Therefore, humid air is less dense than dry air. Humid air will rise in dry air. Gases have different densities, but they will not layer out in the atmosphere. We do not live in a world where carbon dioxide is blanketing Earth's surface with layers of oxygen and nitrogen above, and water vapor at the top. This is because of circulation. Wind is a notable factor in the troposphere and lower regions of the stratosphere, and it stirs up all the molecules. In the upper reaches of the atmosphere, air movement is insignificant.